which is available on a renewable basis. So one of its advantage is that it's actually much more dispatchable in the energy structure as compared to solar, wind, which are much dependent on the the availability of the solar intensity or the wind intensity for their functioning. So the sources typically are called as feedstocks. So the typical feedstock for biomass range from dedicated energy crops, which are specifically grown for the purpose of producing more biofuels, and like sorghum or other crops like that, or switchgrass for instance. And then there are agricultural crops or the forestry residues and main products like virgin wood, and then there's biomass processing residues and the municipal waste and the aquatic crops and animal waste. So the application of biomass is depends strongly on the type of feedstock you're using. For instance, specific energy crops are just going to have the biofuels. For instance, the two major types are ethanol and biodiesel. Ethanol has been widely used since as an additive to petroleum-based fuels because it reduces the toxic air emissions and increases the octane for increasing the fuel efficiency. And for biodiesel, it has some marginal benefits to the air quality as it has relatively less emissions as compared to the fossil fuels like diesel and petroleum. So the conventional use in the energy sector is based broadly of three kinds. Firstly is the biofuels used in the transportation. Then there is the biopower, which is the biomass to electricity generation. So nearly 23% of the electricity among the renewable electricity in US came from biomass actually last year. And the total electricity contribution from the renewable energy sector is around 7% currently. And then there are bioproducts like chemicals for products which are normally made from petroleum. So the idea is normally the conventional use in the energy sector is decreasing the carbon footprint or the energy footprint up to some extent, but it's not so. So this is a typical cycle of what looks like from how the biomass is generated from different sources, and then how it's used. Here it's the template is on the electricity actually. So we have to look at how biomass conversion actually takes place to understand why there is a need to actually strive for more sustainable processes through agriculture to actually achieve the goals which we are looking at in terms of the US energy sector. So biomass conversion typically happens through three different types. Firstly is the biochemical, it can be thermochemical, and it can be photobiological. I'll be going through each one of them in detail. So the biochemical actually uses the enzymes and microbes, which is referred to as biocatalysis, and they have two processes. First is the hydrolysis of the carbohydrates which are in the biomass, and that is converted into sugar, which is then fermented with the help of yeast and other enzymes to actually get the biofuel which we desire. So it's mostly for the biofuel generation. Then there's the thermochemical conversion, which takes the heat energy and the chemical catalyst to actually give, in the anaerobic conditions, to give a gas mixture which is also known as syngas. It's a mixture of hydrogen, methane and carbon monoxide, which is then actually so to avoid to actually being escaped, denuders or some other technologies are actually used to capture that gas and use it more efficiently. So it's so it gives an array of product. It's like you can think it to be analogous to the fractional distillation of petroleum. So like petroleum gives the fractional distillation of crude oil gives you an array of products. Similarly, the thermochemical conversion of biomass also gives an array of products ranging from fibers or biochar, which I will be proposing as a sustainable option through agriculture, and other products as well. So the photochemical conversion is something of a new technology which have been recently explored. So it uses algae and other biological active catalysts to actually use the normal natural process of photosynthesis to synthesize the fuels or other products from the biomass. So there is a additional link for somebody who's interested to look at more. So there's a microalgal biofuel generation which was done by collaboration between the National Renewable Energy Labs and US Air Force as a joint research. So it's basically the photobioreactors. It's termed as the photobioreactors actually used for this process. So this is a schematic of how the net. So it's a schematic of the biorefinery, which entails all these three processes which I discussed previously. So the residues, the top portion represents the biochemical process, whereas there is the syngas, which is then cleaned up to actually give you different array of products ranging from fuels, chemicals, and different cellular materials. So the key is actually the thermochemical conversion, which actually gives the cellulose as a process where we can actually utilize that to get more sustainable products like biochar, which can reduce the carbon footprint or energy footprint of the biomass production. So the potential actually lies in agriculture. You have more than 100,000 of dry tons per year being generated across US. So in case of the agriculture Midwest, if you look at the crop residues, or if you look at the forest residues which overlap with some of these areas, even in the eastern United States and the Northwest. So why agriculture for sustainable application? So by 2030, the goal is to have 5% of nation's power in terms of US, and 20% of the transportation fuels, and 25% of the chemicals to come from biomass actually. So if we want, that is a target, then naturally it will put a pressure on the growth of biomass through the agriculture or through the forestry. So instead of looking, so the improvement of technologies within the biorefinery process is one thing, but addressing the problem from the root, that is the agriculture, should be the main goal. So what are so to overcome challenges, we need the challenges basically are that there will be a lot of fertilizer usage if we want to get more of the biomass from agriculture, and for the biofuel power industry and the chemical production. So with fertilizer, normal problems are eutrophication, so the increased runoff of nitrogen into the water sources. There will be excess emissions of ammonia, nitrogen oxide, methane, and nitrous oxide, which is a potential 100 times more potent than carbon dioxide as a greenhouse gas. So there will be naturally air and other climate issues. So as I discussed earlier, that the biochar can actually be produced by the pyrolysis or the stage of the thermochemical conversion in the biorefinery. So you have those syngases, but they can be addressed instead of being released into the air. And then the solid residual is actually the biochar. The benefits of biochar includes the thing that they optimize the nutrient concentration or the ratio in the soil. So that it's not being proposed as a replacement for nitrogen fertilizer, but it can be an amendment to the nitrogen fertilizer. So the soils where you have lesser ratio of the carbon actually, so which results in lesser yield of the crops. So with the use of biochar, you can actually increase the carbon content and optimize the carbon nitrogen ratio, which results in high crop yields. So, and naturally, when you're using less fertilizer, you are emitting less agricultural pollution. You are avoiding the chances of eutrophication or the leaching through the runoff into the water bodies. And most importantly, it retains the moisture in the soil and also replenishes the oxygen, the carbon, organic carbon into the soil for a much longer time. So the oldest instance of biochar has been found in the Amazonian forest, where the traces of the biochar-like substance have been found to persist for around thousands of years. So they can actually sequester, so they can act as a major source of carbon sequestration in agriculture for millennia. So this is a test case, the real test case scenario of how biochar perform against or with the nitrogen fertilizers. So you can see on the right you have the crops grown just by using the nitrogen, phosphorus, and potassium fertilizers, where on the right you have the biochar, and there's a human yardstick in place. So you can see the differences how the application of biochar along with the nitrogen fertilizer significantly helps the crop yields. So these the crops here is the corn, which actually is the one of the major. So the agriculture north Midwest in US is actually mostly the crop belt. So that is something which can be actually implemented in US as well. So these field sites are in Australia and Japan actually. So on conclusion, I would like to say that biochar, inclusion of biochar as a sustainable process to make the biomass, the refinery process more sustainable will not only yield benefit in the crop yields, but also mitigate air and water pollution and limit the adverse impacts of the whole life cycle of the biomass, and improve conversion technology along with the sustainable agriculture is the key for this process. Thanks.
Good question. So if I'm a policymaker and I'm trying to decide which source of biomass to favor as a transportation fuel, for example, what sorts of factors should I be considering when making my decisions, which ones to maybe subsidize or favor and which ones not to?
So the problem with the biofuels in the sector is that we have a targeted yield of energy crops which are just used for that specific purpose. So if we opt for something which actually benefit both the agriculture yields and also can be the crop residues can then be utilized for the biofuels as well. So that should be actually implemented because that will reduce the carbon footprint much more effectively. So implementation of like usage of biochar in conjunction with the nitrogen fertilizer will actually reduce your carbon footprint in the agricultures as well. So if you're looking at the whole cradle to grave life cycle of the biomass, so that option should be something which like those control technologies or the farming techniques which actually kind of encourage that pathway more should be actually subsidized or should be incentivized more.
Sort of flip around Richard's question. So Richard assumed that we want this for transportation fuel, and what should we use it for, or how should we make it transportation fuel? What if you're a consultant brought in to a region that you're not familiar with before, and they have some excess biomass, but it's not clear whether it should go to a transportation fuel or to biomass for electricity generation or to biochar, or if you showed so many different ways that the biomass can be used. What would be the key features of the region? What would you want to look for to make your recommendation about how that surplus biomass should be used?
So firstly, like looking at the different sectors, like where exactly it is needed, whether it's the financial possibilities of implementing it, whether it's needed much more in the. So if the region, for instance, has a problem of the dispatchable electricity generation, so that is somewhere where the biomass will actually is much more suitable to be implemented as such. If there's a need of if there's a lot of transportation activities being going on there, so that will kick in the need for the transportation the biofuel generation as well. And so looking at, and the crucial part will be, so because I'm proposing agriculture as a way for that, so if there are actually a lot of agriculture activities going there or not, so that will be the key question which needs to be like factored in, which needs to be seen first.
Okay. So it's a great answer in terms of the end need. It's saying, do we need more fuel or do we need more fertilizer,
more dispatchable
electricity, dispatchable electricity? But are there features of the biomass itself, like if all of those things, if society has need for all of those things, are there characteristics that would make, there's so, like you said, there's so many different types of biomass. Which types of biomass are best suited for which purposes?
So like the high carbon content in the biomass actually, and if the soil in that region, if the agriculture is happening there, is actually deficient in that particular nutrient, the carbon that's the key question. Or if how much of the nitrogen is being currently used there. So
it's high carbon.
It's high carbon
biomass,
and the soil is deficient in the carbon actually, and there's a high usage of nitrogen fertilizers in that region. So that actually automatically like validates my pathway which I'm suggesting.
Which pathway?
Like using biochar into agriculture for the whole biomass life cycle.